Hello everyone, again welcome to this session. Today we will be talking about, we will be continuing our discussion on the Linux. Still the Linux basics, this is lecture 2. Before I start the lecture, I want to recap, give you a little bit of recap as what we have done in the past lecture. So we covered the history of Linux and Unix. Mainly it has about 50 years of history at this point, started somewhere in 1960s. Unix people started working on Unix with mini computers. Then around 1991 the Linux came into being. The main person who invented Linux is Linus Torvalds. We also looked at why Unix is very popular operating system, and then why is Linux popular operating system. The main reason why Unix is popular is because Unix provides excellent security features, and it also allows multi-user, multitasking, and multi-CPU or multi-processor capabilities. We actually saw and we defined all those terms, what it means. And then Linux actually provides more features on top of that. First of all, Linux is an open system, so you get the source code along with the Linux operating system. And then we also saw how it also has very solid verification features. It's globally verified, so to speak, because there are so many users using Linux and going through all the programs, all the features of Linux, verifying them every day. So more than 30 years of verification experience in Linux. And then it's an open platform, and companies also use some of the commercial aspects of it. And then we also saw the main parts of Linux operating system: the kernel, the shell, and the file system. We defined each one of them as to how they interact with the user. As we saw, the kernel is the lowest level, which mainly it provides the interface to the hardware systems. So it manages the resources, hardware resources, various units, and then also the memory and I/O. All those different parts are managed. The shell actually sits on top of the kernel. And then that provides the interface from the user to the hardware. So in between all these things is the file system, which is essentially we also define what a file system is, how the files are structured inside the Linux operating system. And one key thing that we noticed was all the devices are represented as files. So if you want to actually put something in at the terminal, we simply write to a file, and if you want to read from a keyboard, we simply read a file. So that facilitates all kinds of interaction much more easily compared to, say, even Windows operating system, where you have to actually start a process and then basically use the process to communicate to your I/O devices. We also saw how to use the shell. What exactly a shell is, it is essentially a command interpreter. So basically, it's when you invoke a shell, it comes up with a prompt. The prompt could be shaped like a dollar, percentage, a greater than sign, things like that, and each one represents various shells. And we saw a couple of shells like the Berkeley C shell, the Bourne shell or the BSH, and then the Bourne again shell, which is the BASH or Bash. The Berkeley C shell is also nowadays it's called the TC shell, which provides additional capabilities on top of the original Berkeley shell. Then we got some basic introduction into the commands. the commands like ls. Ls is the list command. We also saw the command structure inside the Linux operating system, which is command followed by options followed by arguments, and then we saw like a couple of commands ls and cd. Ls is the list command which lists all the files in a given directory, and then we saw like various options ls minus x, ls minus l, ls minus a, ls minus t, ls minus r, various options that we saw. And then also like on cd is the change directory, which allows us to go from one directory to another, and this is essentially by again it has many options, and also like arguments. It needs one argument minimum, which is well, I wouldn't say like it needs one argument minimum. You can also like give it no arguments, and you'll see like I mean I want you to see what happens when you do just a cd with no arguments. Where does it go? Where does it take you? Try that experiment. It's just a fun experiment. Otherwise you need one argument, which is the destination directory. If you don't specify any destination, what happens? So that's something that you can do when you get to play with on the Linux platform. So I also have a couple of activities for you based on the lecture 1. These are something that you can try it out when you get a chance to play on the Linux platform. Number 1 is you can type man. We also saw this man command, which is a manual to get details about any of the commands. So man bash is as you know is the shell. See what happens whether it is man bash and the man pcsh. These are two shells, so you can get more information about the shell, how to move the shell, what are the options. Again, the shell also follows the very similar command rules that we know about already, which is followed by the options and then the arguments. So try it out, see what happens. I also ask you to do this other activity, which is you have a file structure, which is you know the slash represents the root, and then there is a, b, there's a directory a, and then under the directory a you have b and c, and then under root you have also another directory called b. Under that you have directory e. So I want you to write 2 cd commands to go from B to E. Basically one will be an absolute command, the other one is a relative command. Relative command means using where you are and then where you want to go, that is the relative command, and then the absolute command is just follow from the root, whatever its absolute path. So try it out. I think it's a fun exercise. It just gives you some more understanding of how the cd command works. So with that we will start today's lecture. Today I'm going to cover more of the commands themselves. We will look at various commands and see how we can make use of them. So I'm going to start from where we left off. This is the last. I just wanted to again reinforce on the cd command. Couple of things we didn't talk about. Some of the stuff we talked about the tilde to represent the home directory. You can also type cd/home/ which takes us to the /home, which may not be your home directory. Your home may be like /home/ your username. In this case, let's say like AACPER is the username, so it goes there. Now you can also type in like from the home cd cper, and that takes you to the next level. And then from there, like I mean, we know that the dot dot actually moves back one level up. So if you do a cd dot dot, it takes us back to the slash home. And then if you do like cd dot dot slash dot dot from the home from your ASCPR, then it takes you to the root directory. So you can see like I mean how to navigate, and now you can go from one directory to another. And as I said, like if you just do the previous exercise, that will give you like a good grounding as to how to navigate using the cd command. Now let's move on. The next command that we are going to talk about is the mkdir, or in short we just say makedir. So makedir command allows us to create new directories, and the new directories can be created under the current directory, or if you give like an absolute path, it will also create wherever you want it to be created. So here essentially the syntax is makedir followed by the directory name. So again here makedir is the command, and the directory name is the argument. You can also use certain options. For example, the -p. This will create the directory tree the tree. Essentially, like I mean, it creates this whole tree, which is dir1 followed by dir2 followed by dir3, meaning the dir1 is the top level. Under that you have the dir2, and then under that you have dir3. And then you can also do makedir dir5, which is we are just creating a new directory called dir5, and then we say cd pound $. So the $pound has a meaning. Here the $pound means the argument, the last argument of the previous command. So anytime you start with a bang, it has it basically like the bang denotes the command. So we will see some of the shortcuts actually like in the later stage, or even like I will tell some of the shortcuts as we go along. But this bang followed by the $, the $, denotes the last argument from the previous command. So when we say like cd bang $, that bang $, is a shortcut for dir5. So when you say like cd bang $, basically it moves the cursor from the current directory to dir5, because we already created the dir5. This is a very useful shortcut. I think like I mean many of us use this pretty often. The other shortcut is also like bang bang. If you do the bang bang, that's shortcut for the previous command. And then you can also say like bang, however like I mean put a negative integer, and that takes you back so many levels of command. For example, bang -2 is the command that got executed prior to the previous command. So bang -1 is the same as bang bang, and then similarly like you can go progressively behind how many ever commands that are there. And we will see some more commands which allows you to get these kind of shortcuts, and then you can do this kind of navigation. So the next one that we'll talk about is the use of semicolon. Semicolon is usually a command separator. So this allows us to actually concatenate multiple commands in a single line. So in this one, for example, you can say make dir5 semicolon, then cd to dir5. There's no period actually. So once you do that, for example, it's shown here. It creates the directory and then moves the cursor to that directory. So now you can see the prompt actually, which is here, it is actually this greater than sign. That's actually now in this root slash dir2. So and then here also, like we already learned about this, the cd minus, which is essentially going back to the previous command or previous directory where it came from. This is not that it is going up one level, but whichever directory that was there previously. For example, I can say like I'm in the, I can be in like root slash say like dir1, and then already if I had created a under the root, there's a root dot root slash dir2, and then if I say like for example cd to slash root slash dir2 from dir1, and then if I say cd minus, it actually takes me back to dir1 and not to slash root. So this is the important distinction that I want you to keep in mind. Something that you notice in this particular even window is there are multiple shelves on these in this particular window with various tabs, so you can actually click and go to those things. Again, this is all like the features of the multitasking that we already know about when we learned in the beginning of the lecture. So now the next command that we will learn is cat. Cat is the short form for catenate or catenation. Essentially, like when you say cat and the argument is a file name, once you give the file name, the command interpreter just opens that file and displays each line and until the end of the line, and then it puts it back, puts the prompt back. So this is like you cannot do any edits or anything, but it only like displays the content of the file. So for example, like there is this text file kacper.txt that we have, and when you say like cat kacper, it just scrolls through that all the lines and it displays line by line. So it's VLSI design verification, for Verilog, system Verilog, all these VMM, OVM, and another OVM or UEM actually. So all these are displayed, and then even there is an empty line in this file if you notice the end, and then it brings back to the prompt. So this is again another useful command to see what is inside a particular file. So now the question is, how do we use it? Just by displaying a file through through all the lines doesn't seem that useful, correct? But there are many ways that we can use it. For example, you can copy a file into another file, and that you can use just a cat command to do it. So how do we do it? Let's look at that. So here there is a special character, another character, which is the greater than sign. So when we say like cat to a file, so in this one actually we can keep typing whatever we type in, that goes into this file called fly1, and then when we do the control D, it comes back. So this is one way to enter or edit a file. Not really like useful in the sense that we cannot go back and change things around or move things around. This is like just line by line we just input. So say like if you want to type in like some notes into just a file, you can just do this cat and redirect to a file, and then just start typing your notes, and then it will just create that notes. It's useful in some sense basically. You can also say like in fact cat file1 and then redirect to file 2. That actually lets you copy that file. So you will now have two files, file 1 and file 2, both have the same information. So this is where actually you are using two things. One is the cat command, also the redirection operator, which is the greater than sign. So in this case, when you say like 1 greater than sign, it creates this new file and essentially like write into that file. And if the file 1 is already there, then it will not usually write into that. It will say that hey, this file is there, I cannot overwrite it. In some shells it also allows the writing of the content. So here actually if the file 1 is already exists, then it overwrites the content of file 1. It is true, but sometimes some shells actually like will not do that, and then it comes back with an error. So it depends on like the kind of shells that you're using, but you can, again, this is one of the features of Linux, which is the customization that we already talked about. So now let's see like how we can use this one. So the next slide actually it gives you an example of where it is getting overwritten. Here we displayed initially the cat.text that displays the content. This we already saw, but now when we do the cat greater than cat.text and then we start typing the success is not a destination, and then we do a control D, and then now when we issue the same cat command, the previous command, we see actually that the file has changed and we get only this. Again, try this out, try various combinations of this, and I think you will understand it better that way. Now let's go to the next one, which is a little bit more interesting, which is double greater than. So it is 2 arrows. You can see here. What does this do? This actually is slightly different than a single arrow. The 2 greater than signs actually lets you to append to a file. What that means is the fly 1 in the previous example saw that it contained all these things. Now if you say cat 2 greater than and then say cat.text, and then when you type in the success is not a destination and control D, it will contain all these things, and the next line after this empty line will be this one. So that's the big difference between the single greater than and the 2 greater than. So again, how can you use it? So here there is one way to use it, which is fly 1 cat fly 1 file 2, and then you're saying greater than file 2. What happens into this one? This actually concatenates both these files and writes it into the file 2. Now the question is how do you append fly 1 into file 2? The simple thing is like eliminate this file 3, and then you can say cat fly 1 double arrow file 2, and then whatever the content in file 2 will be will have fly 1 appended to it at the end. So if you want the reverse one, like file 2 to go after the file 1, then you need to reverse the order. Say like cat file 2 append to fly 1, and then that gets appended to. So again another fun command to play with. I encourage you to actually try this out and try it out multiple times and various combinations to just understand how this command works. So here is an example. Again, we first typed in whatever the cat.txt as success is not a destination, and then followed by Control D to break the command. Now the next one is cat and 2 arrows and cat.txt, and then it's a progressive journey. And then now when you do the cat.txt, we get those 2 lines that we enter. So this is another way to enter a data into a file. But still we know like now how to create a file, how to actually work with a file, but it's still not very clear as to how we can write some programs and how to navigate through a file. We will talk about some of the commands later on in this course, but let's go on with this knowledge now. The next one is, now we know that how to copy using the cat, but Linux also supports a regular copy function, which is the command is cp, and cp also has again a number of options, but it has 2 main arguments, the source file and the destination file. So if we, without any options, we say cp file1 file2, it copies the content of file 1 into the content of file into file 2. So this is a very useful command. We use this a lot of times actually in the real life, and the Linux also allows you to actually copy many files to a destination. You can also specify a directory here instead of the file, and then it will create the file 1, exact copy of a file 1, and call it also as file 1 under this particular directory. So here we can say cp minus prf. Again, all these things are having a meaning, and then we'll see what they mean. And then it takes this the files and directories and subdirectories from this catper area, home catper, into the HDD backup area, and it creates exactly like all the files into that. So here you see that actually it's not, the arguments are not the files, but instead they are the directories. So that's why, like, I mean, it's left as vaguely as it is here. The source and destination. The source could be a file name or a directory. Destination could be a file name or a directory. When they are directories, then you need some options to make sure that which files are getting copied. And even like in source, you can use wildcards, which is something we will learn. For example, the star denotes all the possible files, and then you can also like filter them by specific characters and names. So now let's look at why we specify these options, the P, R, and F. What do they mean? So here is a brief look into the options. The -I is an interactive, and it prompts before overwriting. So if a file exists in the destination directory and you're trying to overwrite, it will ask you, hey, do you want to overwrite, you want to append, you want to cancel this or skip this file. So then you can use that particular option to either copy it or to skip it, or whichever one that you want to do. -F is the force option, which is essentially, it doesn't matter whether the file exists, whether it is it's preserved, whatever it is, it basically forces it to just remove it and then it will try again. -P is the preserve mode, where all the ownership, the timestamps, and all those things are preserved, and we will see like what that means, like, because there is a special section on what is file ownership, what kind of things that you can do, and also like what are the modes that you can work on a file. And then the -R is a recursive mode. It's a recursive copy, which means that it goes and finds all the subdirectories and subdirectories of subdirectories, and then it copies everything. So a copy minus RF is a force and recursive, which is used many times. And then the dash U is the update copy only when the source file is newer than the destination file, or if the destination file is missing. So here essentially if you already have something new, and if you are trying to overwrite to the previous version, it will prevent copying from copying the previous version. So very useful feature. So the CP minus RF is, as I said, like it's used more than what you can imagine in day-to-day operations. Now, if you want more details, do you know how to get it, or you get more details on CP? So there are two ways. We talked about this earlier. One is the man CP. Try that out, see what you get, and also like CP dash help, which should give you all these options and what are the different arguments. A short version of that. The man will give you like more details. So now let's move on to the next command. This is MV or we just call it move. The move command is different from CP command because move command physically takes the file and then moves it over to the new destination. So in the Windows world, you can it's analogous to cut and paste, whereas the CP command is more like a copy and paste. So again, the arguments here are the source and the destination, and you can also rename a file, which means that the destination could be specified as a file name rather than a directory name. So if you specify the directory name, the names are preserved and it just it moves over to the new directory. But at the same time, if you specify a new file name as a destination, then it moves it and also changes and renames the file to the name that you wanted, that you selected. Again, there are many options. Here there is one of the options that is mentioned, which is the -I, which is interactive, which is if it is trying to overwrite a new file, it basically asks you to confirm whether you really want to do it or not. So again, another nifty feature. Again, for getting more help on this command, I want you to type in the man move to get more help. So let's go to the next one. The next one is the RM command. RM stands for remove. So essentially, like you use RM to remove any file name. Again, you have to use it extremely carefully. Unless you want to do it, don't do it, because the deletions are permanent in Linux and Unix. So once you delete a file, it goes to the heap, and essentially the contents are lost forever. Maybe governments should use this so that you can't trace any of the files too. Maybe. Anyway, so RM file name, that's the command. Again, it has many options. RM-I, basically it's interactive, where it prompts you before deleting a file. It asks you, hey, do you really want to delete this file? And confirms that, and then only deletes. RM-RF is the recursive and force, as we saw. So it basically goes and recursively deletes all the files and subdirectories and directories from under any of the the source or the argument that you specify. And rm minus rf also does not prompt when it tries to delete the file. So it's really a dangerous command. If you go to the root and then they say like rm minus rf, boom, everything gone. So don't try to do this. And then here actually like it's like rm minus rf, that star, the little star here. This means all the files. In fact, you can also specify star dot star, which is it also means exactly the same thing. Whether there's a character or not, I mean, if there is a file, it just deletes everything. So this is the most powerful command I will say in this in any of the Linux platform. So don't ever do this one, rm minus rf star. If you do it from your home directory, the entire home directory is gone. If you do it at the root directory, the root is gone. So I mean, there are several mishaps that happen because of using this rm minus rf star or rm minus rf star dot star. So now let's look at the next command. This is rmdir or rmdir. Again, rmdir is used to remove any directories. So as you know, as we saw, like rm, just the simple remove command is typically used to remove a file. Even though, like I mean, if you use the rm minus rf, the associated directories can also be removed. But rmdir specifically removes a directory. So here in this example, you do an ls of the home directory and see like all these files axirtl, axirtl.zip, copy.tar, all those things. Now there is like a cacper and cacper1. So see the color differences, right? So this OVM reference is green. All these TC, Raghu, and Spurti, copy, and all these things are blue, and then you have red, and then there are black ones. So typically the black ones are the ASCII files. The red ones here are the binary files, and then you get the blue ones, which are mainly directories, and then the green one is some other type that it cannot detect. So it basically it's a PDF. We know that actually. So it is tagged as green. So this is one of the things that some of the shells provide, which kind of colorates the various files based on its contents. So it is very easy to see that okay, how many directories are there? Oh, okay, I have cacper as a directory, cacper1 as a directory, axirtl as a directory, ovmtc as a directory, and then Raghu, Spurti, and Udaya directories. So now I can go and actually remove, like say rmdir cacper1, which is this particular directory, and then if you do an ls command, that particular thing is missing. And here you can also say like ovmtc, but then it comes back with a prompt saying that hey, you are trying to remove a directory which has content in it, which has some files in it. So I cannot do this. So that's this message, the directory not empty message. So if you want to do it, there are two ways of doing it. One is you can say like rm ovmtc /star, and then first remove all the files and then issue the rm ovmtc. That's one way to do it. What is the other way? Can anyone guess? It's the rm minus rf. So recursively go and remove, and that also removes this particular directory. So again, Linux actually provides good features to actually work on this, to for all the commands, so that you don't have just one way. You can do it in multiple ways. You can be very creative in your approach. So now let's go to the next one. The next command that we will learn is the pwd. pwd stands for present working directory. So what does that mean? So this is where the prompt is. It's almost saying that this is today, and what is today? Today is where you are, right, at this point of time. And then so essentially the pwd, when you say it, gives you which directory that you are currently working on, or where your prompt is. Okay. So again, you are in now /home. We know that actually from the first one, and then you have various files. We did an ls command. So one thing that you notice is also, like, I mean, this 404. This could be a machine name. Currently, like, I mean, that's what it looks like. Some shells also display the command number. So if you're running the first command, then it will say 1, 2, 3, 4, etc. In this case, it looks like this is a machine Cacper 404. So the Cacper 404, you go into the home directory. You have removed the Cacper 1, did another ls, and then the OVMTC, that is this is all like the previous command, basically, where we try to remove that, and then it said basically, okay, the directory is not empty, I cannot remove it. Now you issue the pwd command. Basically it comes up with where it is today, where it is currently, which is the /home. So that's why you see the /home here, and then it continues on. So this is again a very useful command, because sometimes the directories can be like very long. Like you can be under A/B/C/D/B/E/F. It can go all the way up to, like, say, Z, and then in the prompt it only displays probably like the Z. So now you want to understand what is my present working directory. So the pwd will give you the exactly where you are. Okay, so this is something like a GPS. So now pwd gives you where you are, but still you have to know where you want to go, and then based on that you can do like cd commands, ls, things like that. So this again very useful command to keep in mind. So now the next command that we'll study is the less command. So we saw already the command cat. So less is very similar to the cat command. In fact, we should start with more, and then we can say like less. But more and less are pretty much more or less the same, similar type of commands. The only difference between the cat and the less is, in less actually it displays the file, but it doesn't go back to the prompt. So it stays within that file, and then so it lets you go up and down the file. And the interface is similar to an editor interface, even though you cannot edit the file, but you can navigate inside the file. So if file is too big, then it first displays only a portion of it. It doesn't display the whole thing like how the cat does. Basically, it just runs through the thing and then it comes back to the prompt. Instead of that, the less command actually displays the file one page at a time, and then it lets you navigate. Usually you can go forward by just pressing the space bar, or you can go back by just typing B, just pressing B, and then each B will go back one page. There are some other additional stuff. One is the use of slash to search within the file. So you can say slash and then followed by a particular string, and then that command will search for that particular string inside the file to see whether it is present, where it is present, things like that. And then for quitting the less, you just simply type q and then it will quit. There are additional commands inside of less, which is one is the percentage command, %g, which takes you to which displays where what is the current percentage or the current line, how much percentage of the file is covered by the current line, or where exactly the current line is in the file. The lowercase g and the uppercase g actually they take you to the first character of the file and then the last character, or first line of the file and the last line of the file. So uppercase G takes you to the last line and lowercase g will take you to the first line. So again this is the less command is mainly used for inspection, and you can also specify like these additional options like -c will clear the screen before displaying. So if there is any residual stuff and it's a small file, you will still like see from the top of the terminal all the way down. And then +n is where n denotes the number of line. So say like +10, it starts printing only from the 10th line onwards. So this is again another thing to inspect files. So you want to actually look at a file without actually editing it, touching it, then the less is your command to do that. Again, touching is another thing. When you open a file for reading alone, you're not changing the timestamp. You don't want to say that hey, I edited the file. It's only reading. If you want to edit the file, then as soon as you edit, the timestamp changes, and then it is a new timestamp will be put in based on when you read the file or when you started reading the file with the right option also. So we will talk about some of those things in the last section where we'll talk about the file system and how to interact with the file system. Now here is an example of less command. So in this one it's a very short file, so basically it displays this in the entire screen and then just say end. So now if you type in q, then this window will quit. You can actually navigate using the G and -G, G and uppercase G that I mentioned. In this file is too small, so you cannot see much. But if the file goes into multiple pages, then it takes you to the first character and the last character respectively. Here actually even the prompt is missing because I think like it displayed the whole page, and then basically once you do the Q, then it will display go back to the prompt. Here it doesn't look that interesting, but in reality if you have a netlist, for example, you can search through the netlist to find a particular component. You can also search through timing reports to understand where the maximum delay is, things like that. So again, the less command has a lot of usefulness in today's programming. In terms of inspection mostly. Okay, so let's go to the next one, next command, which is the head. The head displays top part of the file, which is the starting point, and then you can also make it display more lines, but the default is 10 lines. So if you just say like head and then the file name, it displays the first 10 lines in that file. And then the -n essentially allows you to change the number of lines to be shown. So you can say like -n4, then it will display the first 4 lines. If you so the various options are there, like so here the example is head-n50 file.txt displays the first 50 lines of the file.txt. Head-18 file name without the n also, it also works, it displays the first 18 lines of the file. So why is this again important? The reason is the head command is used in many places where you want to make sure that the file is created and the file has all the proper input recognized. Another one is if you know that there is a splash bar to denote a particular program and you want to know like version from that program itself, then you can do a head of that program or the log file, and then you know that okay which version it is using. Yeah, other ways are basically if you display the first 50, probably that's where all the IOs are all covered, so you know exactly like how the what are the IOs that are needed to run the program. Okay, so we'll see an example of head. Here the linux.txt essentially it displays the first 10 lines of that. So 7, 8, 9, 10. So you can do this many different ways essentially. So now a complementary to head is the tail command. We'll also see this one. A tail command actually displays 10 lines of a file, but it doesn't display the first line but the last line. So the same as head command, but only thing is this displays the last 10 lines of a file. So again, why is this important? Okay, we'll see in a bit, and so here also like you can give the same options, the -n and the number, or just dash number. This changes the number of lines differently, and there are other options too. One of the options that we always use is the -f option. The -f option actually gives on a continuous basis the last 10 lines, so it constantly updates it. It does not go back to the prompt. So why is this important, or why do you need this kind of a feature? Because the tail -f and then the file name, it could be a log file, and then you can actually track how the program is working and how the log file is changing over time. So now you can say like how the program is actually progressing, and then if you see anything wrong with that, you can put a stop to it using Control C. And in fact, to break the tail -f, you need the Control C to come out of it. The same thing basically like you can apply to the program itself. If you see something wrong in the running of the program, you can put a stop to it. And this is it does not change the timestamp on the file name. So if the file name is getting written out and you are worried about changing the timestamp, you should not worry about it if you are using a tail -f. So now let's look at how the tail is used in a file. So here we specify tail just linux.txt, and it displays the content of that particular file, but only the last 10 lines. So if it has more than 10 lines, those lines are already omitted in this example. So as I said earlier when we talked about the less command, the command that goes along with the less is what is called the more. So more is very similar to less. It displays the files and it displays one screen at a time, and It's again as very similar to the left that we already know about, and again it has many options. The dash C clears the display before actually clears the screen before the display actual display, and then dash N displays the first N lines of the file, and the plus N displays the lines from that particular N line. And then you can also just see the next set of lines, next page full of lines by just pressing enter. It's the same concept basically. In the left we pressed the space bar. Here we press enter to advance to the next page. So one use of the more command is shown here. So we do a ls. Ls is the list command, we know about that, and then we know that minus LA, L stands for the long form, and then A is basically all the files, which includes the dot files. So here you see like the auto FSK is a dot auto mount is a dot file dot CSHRC. It also displays these files which are missing when you just said ls or even ls minus l. So and then it also displays all these things. So here there are a couple of things to note in this command. One is the ls minus la, which we already learned about. Then the slash, which is the root directory that we know about. There is a special character which is the pipe. We call it pipe command. It's actually a command. And then the more. So the pipes and T's are something that we will learn later on. These are the commands to change the command flow itself, basically. So here in this one, what we are saying by using this pipe is do the ls minus la on this particular directory and send that output to this program, and this program is more, so it displays your directories page by page. So the first page has all these elements, then it will say like more, so if you press like enter, then it will show the next page. Usually the more command exits out when it comes to the end, similar to the cat essentially, whereas the less will still be inside the program. So I think like that is one of the probably the difference between a more and a less. But I guess this gives you a very good understanding about additional commands. We will take up from this point onwards the next time around. We will go into more deeper into the Linux now. Now that we understood pretty much the basics, we will see what do all these characters mean. What does this mean? What does this mean? Then here how the date, time, year, extra are represented. Even like these things, what do they mean? So we will learn about those kind of things in the next session. So again, thank you very much. Thank you for listening. Again, during the next time, I will again recap this particular lecture, and then we will continue from that point. Thanks once again.